In this video, we're going to talk about how to solve quadratic equations with real solutions using the quadratic formula. So the quadratic formula can be used to solve quadratic equations that are in standard form, which is ax squared plus bx plus c equals 0. So here's the quadratic formula, and I'm sure that all of you have already seen this before. So quadratic equations can have one real solution, two real solutions, or no real solutions. And we can see this from the graph. If the graph intersects the x-axis at 2 points, then we have two real solutions. If the graph intersects the x-axis at 1 point, we have one real solution. And if the graph kind of hovers above the x-axis and doesn't ever cross it, then we have no real solutions. So the quadratic formula can actually be used also to predict the number and type of solutions to a quadratic equation. And the way we predict is using this value called the discriminant. And the discriminant is basically the radicand in the quadratic equation. So if we call the discriminant d, d is going to equal this value that's under the square root sign, this b squared minus 4ac. So what we're going to be doing in these problems is taking a minute to go ahead and calculate this value of d. And then once we do that, we can predict the type and number of solutions. And we can also just plug that d value right straight into the quadratic formula. So the number and type of solutions can be predicted by the value of the discriminant. So for example, if the discriminant is positive, okay, if d is greater than 0, that's when we have two real solutions. So if d is a perfect square, the equation will have two real rational solutions, right? Because what will happen is when you take the square root of d, you'll get an integer, and then this will all simplify to a rational number. If the value of d is positive but it's not a perfect square, then the equation will have two real irrational solutions. Because what will happen is we won't be able to get rid of this radical, and so we'll have a radical in our final answer. Okay, so we'll have two irrational solutions. If d is equal to 0, that's when the equation will have one real rational solution. Because what will happen is this plus or minus will become plus or minus 0, so this entire term will disappear from our quadratic formula. So we'll just have negative b over 2a, and that's how we end up with one solution. If d is less than 0, if d is negative, the equation will have no real solutions because both solutions will be complex. So if we think about it, you'll have a negative value under the square root, and that's going to result in a complex number when we simplify. So we'll see more about this in the next video. So just an important problem-solving tip. After making sure that your equation is in standard form, ax squared plus bx plus c equals 0, it can be very helpful to write out the values of a, b, and c before you plug into the equation. Because there's a lot of negative signs and positive signs sometimes floating around, and it's good to keep track of them. So for example, in this problem, we have x squared minus 4x minus 41 equals 0. And remember, if we don't have a coefficient in front of x squared, that's just a 1. So that's going to be our value of a, negative 4 is our value of b, and then negative 41 is the value of c. But I just go ahead and list these out every time I do a problem because it helps me keep track of everything. Another problem-solving tip is to simplify whenever possible. Okay, always check the radical and check whether you can simplify the radical. Then you also want to simplify by dividing every term in the expression by a number if it's possible to do so. So for example, if we continue with this problem, x squared minus 4x minus 41 equals 0, if we plug into the quadratic formula, we get 4 plus or minus the square root of 180 over 2. Well, the square root of 180, we can make it better. That's going to be the square root of 36 times the square root of 5. The square root of 36 is 6, so we have 4 plus or minus 6 square root of 5 over 2. Well, notice that all of these values, 4, 6, and 2, are divisible by 2. So I can use that to simplify this now. So I can reduce this by 2. I can do 4 reduced by 2 is going to be 2. And then 6 is going to turn into a 3. So that's how this whole fraction will simplify into 2 plus or minus 3 square root of 5. Okay, so always simplify whenever possible. So when we solve a quadratic equation with real solutions using the quadratic formula, we're going to always start off by rearranging our equation if we need to so that it's in standard form. Then we'll list out the values of a, b, and c and calculate the value of the discriminant. Based on the discriminant, we can predict the number and type of solutions, and then plug all the values we have into the quadratic formula to find the solutions. We can simplify the radical if possible, and then simplify the terms in the expression if possible. And remember that the plus or minus can result in two solutions. All right, so let's now get into some examples. So we have 2x squared minus x minus 6 equals 0. So my first step is to make sure it's in standard form, and this is. So I can just go ahead and now identify the values of A. B is going to be -1, and C is going to be -6. So I have A equals 2, B equals -1, and C equals -6. So let's go ahead now and start off by calculating the value of the discriminant. So I have D equals B squared minus 4AC. So that's going to be D equals -1 squared minus 4 times 2 times -6. Well, -1 squared is 1, and then I have minus 4 times 2, which is 8. 8 times -6 is -48. So I have 1 minus -48, so that's going to turn into 1 plus 48, which is D equals 49. Well, let's look at 49. 49 is greater than 0, so I know I have two real solutions, right? And then 49 is a perfect square, so I know I have two real rational solutions, okay? So that's how the discriminant can help you predict. Now let's go to the quadratic formula and plug everything in. So I have x equals -b, so -1, plus or minus the square root of 49, right? Because I can just plug in d, and that's all over 2 times 2. Okay, so that's going to simplify. I have x equals 1 plus or minus the square root of 49, which is 7, and that's all over 4. Well, that 1 plus or minus 7 over 4, I get two solutions, right? I have x equals 1 plus 7 over 4, and I have x equals 1 minus 7 over 4. All I did was take that plus or minus and separate it into two solutions. Well, 1 plus 7 is 8. 8 divided by 4 is 2. So x equals 2 is one of the solutions. And then 1 minus 7 is -6. I have -6 over 4. Well, I can actually reduce that, right? -6 and 4 are both divisible by 2. So this is going to be -3 and 2. So my other solution is going to be -3 over 2. And if you really want to write it as a decimal, that's -1.5. So x equals -3 over 2, or x equals -1.5 is my second solution. Okay, so you see we did get two real rational solutions as we predicted. So now let's try solving this equation. So we have 3x squared plus 4x minus 5 equals 0. Okay, so 3 is my value of A, 4 is my value of B, and minus 5 is my value of C. Just going to list these out. A equals 3, B equals 4, C equals -5. So D is going to equal B squared, so 4 squared, minus 4 times A, which is 3, times C, which is -5. So I have D equals 4 squared, which is 16, minus 4 times 3 is 12. 12 times -5 is -60. So 16 minus -60, that's going to turn into a plus, so I have D equals 76. Okay, 76 is a positive number, so we know we have two real, and then 76 is not a perfect square, so that's going to be irrational, right? We're going to have two real irrational solutions. And so that means we're going to have a radical in our final answer. So let's go ahead now to the quadratic formula and figure out what those solutions actually are. So we have -b, so -4, plus or minus the square root of 76 over 2 times a, which is 2 times 3. So let's now work on simplifying this. So the square root of 76, I can actually factor out the square root of 4. So I have -4 plus or minus the square root of 4 times the square root of 19 over 6. Well, that's going to simplify. That square root of 4 is 2. So that's going to give me x equals -4 plus or minus the 2 times the square root of 19 over 6. Now I want to look at all these terms and see if I can simplify it further. Notice that every single term is divisible by 2. So I can go ahead and reduce everything by 2. So I have -2. The 2 is just going to become a 1. And then 6 is going to reduce to 3. So this is going to give me x equals -2 plus or minus the square root of 19 over 3. So notice that we get two real irrational solutions just like we predicted using the discriminant. Remember that the plus or minus tells us that we have two solutions. All right, now let's try this example. Well, this is not in standard form, but that's okay because we can just go ahead and rearrange it. So I want this to be set equal to 0, so I'm going to go ahead and subtract 11 from both sides. So when I subtract 11 from both sides, I get x squared minus 10x minus 11 equals 0. Okay, so now I can identify the values of a, b, and c. So there's no number in front of x squared, so that's a 1. So I have a, negative 10 is b, and negative 11 is c. So I have a equals 1, b equals negative 10, and c equals negative 11. All right, so let's first figure out the discriminant. So the discriminant is going to be b squared, so negative 10 squared, minus 4 times a, which is 1, times c, which is negative 11. So we have d equals negative 10 squared, which is 100, minus 4 times 1, which is 4, times negative 11, so minus 44. Okay, minus negative 44 is going to become plus. So we have d equals 100 plus 44, which is 144. So this is greater than 0, so we know that we have 2 real, and then 144 is a perfect square, so we have 2 real rational solutions. Okay, now let's go to the quadratic formula and figure out what these solutions actually are. So we have x equals negative b, so negative 10, plus or minus the square root of d, so square root of 144, and that's all divided by 2 times a, so 2 times 1. So we have x equals 10, right? Negative, negative makes positive, plus or minus the square root of 144 is 12, and that's all over 2. So let's now separate this into two solutions. So we have x equals 10 plus 12 over 2, and x equals 10 minus 12 over 2. 10 plus 12 is going to be 22. 22 divided by 2 is going to equal 11. 10 minus 12 is negative 2. Negative 2 divided by 2 is negative 1. So that means that we get x equals 11 and x equals negative 1 as our two solutions, right? So notice that we do have our two real rational solutions as predicted. So now you can go ahead and pause the video and try doing this example on your own. So here we have our equation already in standard form, so we just label a, b, and c. So a is 5, b is negative 8, and c is 1. We calculate d, we get d equals 44, and so since that's greater than 0, we have 2 real, and then since 44 is not a perfect square, we have 2 real irrational roots, okay? So we're going to use that value of d now to calculate these solutions, and so we have x equals negative 8 plus or minus the square root of 44 over 2 times 5. The square root of 44 can be made better by factoring out a square root of 4. So we have 8 plus or minus 2 square root of 11 over 10. So now notice that all of these terms are divisible by 2, so we end up with 4 plus or minus the square root of 11 over 5. So remember, you can use the quadratic formula to determine the solutions of a quadratic equation. Calculating the value of the discriminant before using the formula can help you determine whether the equation has one real solution, two real solutions, or no real solutions.